Okay, in this video we're going to look at where a derivative will fail to exist. Basically, a derivative will fail to exist if the limit as x approaches a, and this will be the alternative definition, so either definition would work, fails to exist. So let's look at 4 examples where the derivative will not exist. So 4 examples where a derivative will fail to exist. Okay. The first one where a derivative would fail to exist is at a corner. Okay. An example of a corner is going to be like this. Okay. We're going to take a function, and the function is going to come down, and it's going to go back out, something like that. Okay. We all know that's the absolute value graph. Okay, and if we look at this graph, when it comes in from the left, it has a slope of -1, and when it comes in, the derivative has a slope of 1. So this is a corner right here, and the reason that it is not differentiable, it fails to exist at this point because the limit from the left and from the right are not the same. So therefore, when we have one-sided derivatives that differ, that's going to be where we have the derivative failing to exist. Okay, the next example could be at a cusp. Okay, this is an example here of a cusp. Okay, an example of this would be y equals x to the 2/3. Okay, now when this comes in from the left, that's going towards -infinity. So the slope on one side goes towards -infinity, and the slope on the other side goes towards positive infinity, and that's going to be where we have a cusp. Okay. Next, we're going to have a vertical tangent. Please just ignore that background noise. All right, so a vertical tangent could be something like this, where your graph is going to come in and do something like that. That's going to be the graph y equals the cube root of x. Okay, so that's a graph y equals cube root of x. So basically, when it gets in here, we're getting vertical tangents coming in from here and here. So either way, the slope from either side approaches infinity or -infinity. Okay. And the final example that we're going to look at for where we're going to have derivative failing to exist is if the function has discontinuity. That's a big question about discontinuity, but we're not determining if it's a continuous function or not. We're just looking for points of discontinuity. So an example of this would be at u of x. Let's say it's a piecewise function where it goes from -1 to 1, x is less than or equal to 0, x is greater than or equal to 0. If I do that, I'm going to have -1. Okay, so there's my piecewise function. The derivative from the left, the slope is -1. Oh no, the slope is 0 here. But there's a point of discontinuity here. So because of the point of discontinuity, that means there will not be a derivative at that point. So the derivative does not exist wherever we have points of discontinuity.